All right, so today we'll be looking at the rules of indices. Since you've actually learned them, okay, it will be very easy for us to actually discuss these. Okay, so we're going to go through over them and then solve some example questions that I've gotten from your tutorial sheet. All right, so these are the rules here in summarized form, but let's talk about them one by one. Okay, so the first rule, it involves a raised to power m and then multiplied by, not plus, multiplied by a to the power n. So I have the same base here. Okay, so this one here is called the base, and then this one is called the exponent or the power. So I have the same base with different exponents. So how can I combine this using the rules of indices? Okay, so if the base here is actually the same, then I'm just going to write one base. And then if I have multiplication there, okay, I'm going to add the powers. So this will be a to the power m plus n. Okay, so that's the first rule that we talk about when it comes to indices. And then an example of this, or an application of this, would be if, for example, I have 5 to the power 2, okay, being multiplied by 5 to the power maybe 5. So to simplify this, we're just going to write this one base because it's common there. So it will be 5, and then 2 plus 5, that would be 7. Okay, so that would be like 5 to the power 7. So if you multiply 5 to the power 2 with 5 to the power 5, it's the same as just saying 5 to the power 7. Okay, so you can see this one is more simplified than this one, right? Okay, and it saves time. All right, okay, so the other one is the rule that involves division. So this one involved multiplication there. So the other one is I have a to the power m divided by a to the power n. So this one here will just be a, and then since we are dividing here, we're going to subtract the powers. So it will be m minus n, like that. Okay, an example could be in this form. I'll say 2 to the power 6 divided by maybe 2 to the power 3. Okay, so this will just be 2 and then 6 minus 3, which will just be 2 to the power what? 3, like that. Okay, and then if there's a common question that actually confuses students. So if I have a negative in the denominator, for example, if I have maybe 4 to the power 7 divided by 4 to the power minus 9. So if there is negative power here, it usually confuses students. So make sure you take note of the negative. Okay, so this will be 4, 7 minus. This minus here, it's because I'm dividing these things. Okay, it's not the minus on the 9. So it means the minus 9, you put it in brackets like this. Okay, so that would be the same as 4, 7 plus 9, because negative and negative, they'll give me a positive, and that will just be 4 to the power 16, like this. Okay, so that's what we have there. Okay, we'll move on to the next rule. So the next rule combines powers. Okay, so let me write it here. So the next rule combines powers. So if I have a to the power m, and then this a to the power m, I'm raising it to power n, I can actually just multiply the two powers, the m and the n, to just get a to the power m multiplied by what? By n. Okay, I can do that. Okay, and also here, you can do what we call a switch of the powers. So if I have a m to the power n, I can also write this as I take the n inside, and then I take the m outside. So it will be a to the power n, okay, and then this in brackets to the power m. When I multiply those two powers, it's still going to be m n. You can see these are equal, right? Okay, so meaning even these ones are equal here. So a to the power m and then to the power n is the same as a to the power n and then to the power m. Okay, because we are multiplying these powers here, and multiplication is actually what? Commutative. Okay, multiplication is actually commutative. So an example is 2 to the power 2 and then to the power 3. So this will just be 2 and then 2 multiplied by the 3, that would be 6. This one here is also the same as 2 to the power 3 and then to the power 2. Because when I multiply again the powers, it's still 2 to the power what? 6, like that. Okay, so it's the same. So that's another rule that you should take note of. Okay, you are going to be using it as we are simplifying some of those things. Okay, so now the fourth rule is if I have a product which is being raised to a single power. So let's say I have the numbers A and B, they are multiplying, okay, and then I say this to the power n. Okay, so this will be equals to A to the power n and then B to the power n. So the power goes to the A and it also goes to the what? To the B. Okay, the power goes to the A and also goes to the B. So it's the same as if I have A over B. Okay, you can see they're dividing and then I have n. So this n, the power, it will go to the A and it will go to the what? To the B as well. So it will be A to the power n divided by B to the power n, like that. Okay, so this also is another rule. This one here is another rule. So take note of these rules. Okay, they are very important. And then for this one here, okay, for this rule to be valid, you always have to make sure that the B is actually never equal to what? To 0. Okay, so B should never be equals to 0. Because the moment B becomes 0, then the whole fraction becomes undefined or it becomes invalid. Okay, so make sure the B is never equals to 0. Okay, another simple rule that you should take note of is that A to the power 0 is always equals to 1. Okay, whenever A, or I should say A should never be equals to 0. Okay, so any number that you can think of raised to the power 0, it's 1. But if you write 0 to the power 0, this one here is undefined. Okay, it's not 1. Okay, it's not 1. So any number apart from 0, if you raise it to power 0, uh, okay, any number apart from 0, if you raise it to power 0, it's going to give you 1. So meaning if you want, you can put 1 million, okay, like that, to the power 0. This is just 0. Okay, so our lecturer used to teach us a lesson about life using this. He says, if you don't do uh, something, even if it's little, if you don't do something about uh, something that you want to achieve and the like, you won't achieve it. Okay, it's the same as the 1 million to the power 0, because I'm not doing anything to the 1 million. So I mean, the answer there should be 1, right? Not the 0. Sorry, the answer there should be 1. So if you're not doing anything to whatever you have, okay, or you're not doing anything, okay, about what you want to achieve, then you are always going to be stagnant, okay, because 500 to the power 0, it will still give you 1, okay, to still give you 1. But if you just um make like a bit of consistency, for example, if I say now 500 to the power 0.1, okay, you're going to see that we're going to get something. So if I do 500 to the power 0.1, you see that I actually get 1 point something. So the number starts to increase. So no matter how small, okay? So if you want to achieve your goal, for example, you want to pass the exam that you're going to be uh, having at the end of the semester, okay? Or the quiz that you'll be writing soon, make sure you put in effort, okay? Even if it's the smallest effort, just putting effort, it will result into something than doing nothing about it, okay? So make sure you are studying every day, and then that will keep on adding to your chances of actually what? Making it. All right, so the important rule that I was talking about anyway here is that A to the power 0 is just 1, as long as A is not 0. Okay, and then the other one is the rule that involves the negative power. Okay, so if I have A raised to a negative power like n, like this will always be, okay, 1 over this same thing, but with the positive power. So it will be A to the power what? Positive n. Okay, so meaning if I have 2 to the power minus 1, this is the same as 1 over 2 to the power 1. So meaning 2 to the power minus 1 is just the same as half. Okay, 2 to the power minus 1 is just the same as what? Half. If I have 5 to the power minus 10, this will be the same as 1 over 5, but now to a positive power like that. Okay, so that's what that rule says. And then we can look at the last important rule. Okay, there are other ones, but the ones that I've said, they're the most important. So the other one is what allows us to turn a power into a root. Okay, so if your power is a fraction, then you always result into a root. So for example, if I have a to the power m over n, you see that the power is a fraction, right? So this one will always result into a root. Okay, so what root is it going to result into? So the guy in the denominator, that's the root that we are going to result into. And then the m is just going to be it's just going to be a power of that same root that you have. So here, this is the same as root. This is the same as the nth root. Okay, so you can see I've put n there, and then here I'll put m. I mean I put a to the power m. Okay, this here you can also write it as the nth root. Okay, and then to the power what m like this. So you can put the m inside like that. Okay, or you can actually put the m outside like that. It is perfectly okay. Okay, it's the same. Okay, so this rule just requires that the a is actually what? Greater than 0. So a should be a number that is greater than 0, because we know that we can't find a root for a negative number. So the a should be greater than 0. So for example, okay, if I write 4 to the power half, 4 to the power half will be the same as okay, the square root. So if the root there is 2, then we call it as the square root. So the square root, we actually don't show the 2 there. We just write square root like this. Okay, and then to the power what? To the power what? Whatever was on top there, which is 1. So it would be the square root of 4, which is 2, to the power 1, which is just what? 2. Okay, what if I have maybe, let me say what? Okay, I have 8 to the power 2 over 3. This will be equals to, okay, now since there's 3, it means I have the cube root. Okay, I have the cube root. So the root for the 3 is called the cube root. So it will just be the cube root. I'll put a 3 there of 8. And then whatever I find there, I just raise it to power 2, because the 2 is the one that is on top. So the cube root simply meaning what number can I multiply by itself 3 times to get this 8? Okay, that number is just 2. So that would be 2. Okay, that is the cube root of 8, and then to the power 2. So the answer here will just be what? Will just be 4. So that's how we use the power if it's actually a fraction. Okay, so let me give another example. Let's say I have 16, okay, raised to power 3 over 4. So now you see that the denominator is 4. So that's called the fourth root. So it will be the fourth root of 16 and then to the power 3. Okay, but if you want this 3, you can actually just put it there like that. Okay, but I prefer like this because it's easier to actually manipulate. So what is the fourth root of 16? So which number can we multiply by itself 4 times to get 16? That's the fourth root of 16. So that would be 2 multiplied by 2 multiplied by 2 multiplied by 2. So 2 multiplied by 2, 4. Multiplied by 2 multiplied by 2. 4 multiplied by 2, 8 multiplied by 2, and then 8 multiplied by 2, I get 16. So meaning that the fourth root of 16 is actually what? Is actually 2. And then this 2 now, I raise it to power 3, which would just be 8. Okay, so that would be the answer there. So that's how we can use the rules, and those are the rules of indices. So there's a summary here of everything. I've actually put them on the screen here. Okay, so this is what we've discussed. So now, I've gotten some questions from your tutorial sheet, okay, that we're going to use to practice on how to use it, and how to use these same rules that we are talking about. Okay, so these are the questions here. So they're saying evaluate each of the following expressions. Okay, and there are 8 questions there. Okay, so if you don't understand anything, please ask. Okay, so the first one here is 25 to the power 1, 2. So this is just going to be equals to, okay, so here the denominator becomes the root. So that is 2. So we have the square root of 25. And then this being multiplied by the one on top there, which is 1. So the square root of 25, we all know it's 5. And then to the power 1. So 5 to the power 1 is actually what? 5. So that's the answer there. So that was part 1. Part 2, okay, it's more interesting. So it's 1, 9 over 16, and then 3 over 2. So the first thing to do here is actually first to express this mixed fraction here as an improper fraction. Okay, so how do we do that? We say 1, this big number 1, multiplied by 16, I get 16. And then 16 plus 9, I'll get 25. So whatever is inside this bracket here is the same as 25 over 16. Okay, and then outside there I have a 3 divided by 2. So now the denominator is 2 here, so it becomes the root. Okay, so the root for 2 is just called square root. So that will be the square root, okay, of 25 over 16. And then all this will be raised to whatever is on top there, which is what? Power 3. Okay, so now later on, we'll learn about SADs, but here I'm just going to use them. So SADs, okay, they say that if I have a root of A over B like this is the same as root of A divided by the root of what? B. So I'm going to distribute this root to the 25 and to the 16. So it will be the um root of what now? Root of 25 divided by the root of what? 16. Okay. And then everything here to the power 3. So this will just be equals to, what is the root of 25? It's 5. What is the root of 16? It's 4. And then all this raised to power 3. Okay, so this will now be equals to. So now remember the rule that said if I have a power outside, it goes to whatever is on top, and it also goes to whatever is down, right? So this is the same as 5 to the power 3 divided by 4 to the power 3. Okay, so now 5 to the power 3, it's 125 divided by 4 to the power 3, it's 64. So the answer there on part B, or number 2, is actually 25 over 64. Okay, so any questions there, guys? Any questions that you have? Okay, so if you have no questions, let's look at part 3. I hope you understand it. Okay. If you have a question, please don't be afraid. Just ask. So the third one is 3, 4, 3 divided by 5, 1, 2 to the power minus 2 over what? 3. Okay, so what we notice first of all here is that we have a negative power. So how did we say we're going to handle a negative power? Okay, so if I have a to the power minus n, say this will just be the same as 1 divided by a to the power n, right? So now this divided by, I can also write it in a smart way. It can just be 1 divided by a to the power n. Okay, this divided by here, I can actually just write it in terms of the symbols. So that's what I'm going to do here. I'm going to say this is equals to 1 divided by, because there's a negative power. Okay, so it will be 1 divided by 4, 343 over 512 to the power, now the power is positive. So that will be 2 over 3. Okay, so this will just be 1 divided by, and then here now, it means I have the cube root. So it will be the cube root of 343 over 512. And then everything here is raised to whatever number is on top there, which is 2. So this will be equals to 1 divided by, and then here I can distribute the root. So it will be the cube root of 343 divided by the cube root of 5112. Okay, and then everything here is raised to power 2. So this is just equals to 1 divided by, okay, so let's find the cube root of 343. So the cube root of 343 is just 7. Okay, the cube root of uh, the cube root of 343 or 343 is just 7. Okay, so you should try on your calculator to multiply 7, multiply by 7, multiply by 7. You're going to find 343. So I'm just going to say that is 7 divided by, and then what is the cube root of 512? Okay, the cube root of 512 is simply 8. So if you multiply 8 by itself 3 times, you're going to get 512. So that's what I get there. And then this whole thing is raised to power 2. So this will just be 1 divided by, okay? So now here this power goes to the 7 and then it goes to the 8. So what is 7 squared? That is 49 divided by, okay? You have seen how we are using the rules that we are learning, okay? And then 8 to the power 2, that is 64. So what I have now there, if I can write it on top here, it's just 1 divided by 49 over 64. Okay, so this will be the same as 1 multiplied by, so if I change this sign, then this guy has to go on top. This guy comes down. So it will be 64 over 40 what? 9. Okay, so meaning that my final answer will just be 64 over 49. Okay, so that is my final answer there. Okay, it's 64 over 49. So any questions there that we have? Any questions, guys? All right, so I'll presume or assume you guys have understood. So let's look at part 4. So part 4, it's 125 4 over 3. Okay, this one is very easy. This will just be the cube root of 125. And then I raise this to power what? 4. So this will be equals to, what is the cube root of 125? It's just 5. So that would be 5 to the power 4. So 5 to the power 4 is the same as 5 multiplied by 5 multiplied by what? 5 multiplied by 5 again. So 5 multiplied by 5, 25. 25 multiplied by 5, 125. And then 125 multiplied by another 5. It's going to give you 625 like this. Okay, so this is the answer here. Okay, 625. Okay, so let me solve 2 more, and then I'll leave the other ones for you guys to try out. Okay, so you can try them out, and then you send me your solutions. So let me, I want to leave the one which is hard so that you, okay, so I'll leave this one here, and I'll leave this one here. So you can screenshot and try them out, or you can just go to your tutorial sheet. You're going to find them on, is that question 2 or 3? I don't know. Okay, so me, I'm going to solve this, and then these ones I'll leave for you, right? So that we are all practicing. Okay, so the other one there is 81 to the power minus 3 over 4. Okay, 81 to the power minus 3 over 4. So I'm going to say 81 to the power minus 3 over 4 is equals to, okay, so since this is a negative power, okay, then I write this as 1 divided by this, but to a positive power, right? So that would be 1 divided by 81 and then 3 over 4. Okay, this will be equals to 1 divided by this one here now, it will be the 4th root of 81 and then to the power what? The one which is on top, 3. Okay, so now, what is the 4th root of 81? What number can we multiply by itself 4 times so that we get 81? Okay, so that number is 3. So it will be 1 divided by, here I have 3 and then to the power 3. Okay, meaning that I'll just have this one now, I'll write it as 1. This guy, I'll write it as divide by, okay, and then 3 to the power 3, that is going to give me 27. Okay, so this guy here is actually the same as 1 over what? 27. Okay, so I'll leave this one for your practice. You can try it out and then you said your solutions. I'll move to this guy. So the other guy there is um, 8 to the power minus 2 over 3 is equals to, okay, so it's the same principle. So it will be 1 divided by 8 to the power 2 over 3. So this will be equals to 1 divided by, here to be the cube root of 8 to the power 2. So this will just be 1 divided by, the cube root of 8 is 2, and then to the power 2. So this will just be 1 divided by 4, which will be the same as 1 over 4. Okay, so you see that in math, actually, we just do useless things. So this guy is actually the same as 1 over 4, but here we're just trying to complicate it. They're just trying to complicate the simple things. Okay, so we've simplified this to actually 1 over 4. So 1 over 4, who knew that 1 over 4 can look like 8 to the power minus 2 over 3? Okay, so any questions there, guys? Okay, so those are the laws of indices and how we can use them. Do I have any question from you? Any questions from you? Okay, so if there are no questions, I'll end here, but make sure you submit the solutions to this. So you can just inbox me. My number is in the WhatsApp group. Okay, so the number written to Tapo, just solve and then you can send your solutions. I'll be able to guide. Okay, so now, actually, that tutorial sheet that you have, we have full solutions already. So this is the first tutorial sheet that you've been given this semester, right? So you can see from tutorial sheet 1 where we have the sets of numbers, blah, blah, blah. Here, it's how you apply the sets of numbers to the medical field. You can see there are doses there. We've actually solved all these questions and they are available on the website, all these ones. Even these ones. So the ones we are just from solving, I got it from here. This was question 2. So all these other questions where we're simplifying this, expanding expressions, factorizing, simplifying the SADs, these ones, okay. Uh, Again here, this is still SADs, exponents, more exponents, substitution reaction, all these questions here, okay. This is quadratic inequalities. We have actually solved them and the videos are available on the website. So you can just go to discretelearning.com. Okay, you subscribe for this course and then you'll be able to access all these videos. So you can learn at your own time, at your own pace, even in your blankets. Okay, and the good thing is that we also have a mobile app. Then on the mobile app, you can actually download these videos when you go at, for example, to a place where there's Wi-Fi. So you can download the videos in advance. And then once you go back to your boarding house or your hostel or wherever you go, okay, you can actually watch those videos offline. Okay, so you don't always have to have bundles for you to actually learn using our platforms. Okay, so it's a very good platform. uh, we're encouraging you guys to actually subscribe, and then you see on your own the benefits that you're going to get. Okay, because all these questions actually have been solved already. Okay, and there are also topic videos. There are videos to past papers like quizzes, tests, and the final exams that you can actually use to study. Okay, so if you've never seen the website, let me just go here. So you can go to Chrome and then type in discretelearning.com. You go to the website here. Okay, so the website will look something like this. Okay, so it will depend with the course that you have actually subscribed for. But when you go down here, you can see there's math, chemistry, physics, biology. Okay, so any of the courses that you want. So if, for example, it's math, just open math. Okay, once you open the math folder, you are going to see a folder specifically for Unidas first semester. This one here. If you are in second semester, just go there. So first semester Unidas, you just click on it. Okay, you're going to see that you're going to find topic lessons, summarize notes, tutorial sheets and assignments, and then past quiz tests and exam papers. So you can access all this and be learning at your own pace and understanding things clearly. Okay, so if I go to the tutorial sheets here, for example, There are different intakes. So yours, it's January 2026, right? Okay. So for whatever intake that will come in future and the past, so 2025 January intake, all the videos are there for the tutorial sheets. You can be learning because the concepts are the same. 2025, again, the tutorial sheets are there. 2026, so far we've only been given one tutorial sheet, and that one tutorial sheet, we've actually solved it already. Okay, so just open that folder. I don't know why it's delaying. Maybe it's the issue of network and the like. Okay, but when you open this folder, you're going to find the full videos for the tutorial sheet one, and you can access them and start learning at your own pace, at your own time. Yeah, so this one here, you can see tutorial sheet one algebra. If you open it, question one, question two, question three, question four, question five, question six, and seven. We're all aboard here. You can't even get lost. All right, so thank you so much for attending. I'll see you in the next one.